Hello everyone, my name is Mahdi Yusuf from Electronic and Computer Engineering department, and for this seminar topic I will talk about a survey of deep learning based object detection, a paper review. So this is my personal information. Okay, first we will learn about the overview of this paper. This paper is published in IEEE Access Journal in 2019, and the main author is Lisheng Zhao from Xidian University in China. This paper is containing the necessary information to learn about the basic concept of the object detection with deep learning. There is four main topics that will be discussed in this paper. The first is the deep learning method that can be used for object detection. Second is the dataset that will be used for the object detection training and testing. The third is the method to improve the object detection model. And the fourth is the application of the object detection model in real life. Okay, in this section we will learn about the definition of the deep learning, which is contained the definition of the artificial intelligence, the definition of the machine learning, and the deep learning. We will also learn about the difference between them. The artificial intelligence is a concept to create a machine that's capable of doing a human task that require a human intelligence independently without the control from the human. For instance, we can illustrate a machine that can separate between the apple and the orange. The machine must have the intelligence to identifying which one is the apple and which one is the orange. They can do so by using the color sensor and separate the two fruit based on the value from the color sensor. So the machine is have the intelligence to separate the fruit based on their color. That is the basic concept of the artificial intelligence. The machine learning is a subset application of the artificial intelligence that the machine is capable of learning how to finish the task by itself. So the machine will learn using the statistical method to learn the pattern in the data that have been given. In the previous example with apple and orange, if the machine learning concept is applied, we don't need to define the color value for each fruit. We just need to provide the machine with the feature data, and the machine will learn by itself based on the data that have been given. And another one is the deep learning, which is another subset of the machine learning that use the artificial neural network to learn by itself. If in the machine learning we must provide the feature to the machine, in the deep learning we just need to provide the input, which is an image and the label of each image in a form of dataset. And from the dataset, the deep learning model will learn how to classify which one is orange and which one is apple. So by learning the definition of each concept, we can find the difference of each method to solve some human tasks. So for example, the artificial intelligence still need a human to program the machine, like using if else, so the machine can work independently. But in the machine learning concept, the machine can learn by itself based on the features that have been extracted, and the final subset is the deep learning, and we just need to create a neural network that can learn independently to do the task based on the dataset that have been collected and learned by the deep learning model. So it's much easier to us to solve the task with the deep learning model rather than program the machine manually. In this section, we will learn about how deep learning model works and how the deep learning can be used for the object detection task. So the deep learning concept works with using an artificial neural network that can learn the pattern in the data that have been provided. Basically, the inspiration of the artificial neural network is the neural network in our brain. So we can consider seeing the artificial neural network as the neural network in our brain when we want to learn something. So, for example, when we want to learn something, we continuously train our brain by repeating some tasks over and over. So, and then the brain will strengthen some neuron that activate when the task is performed. And after some time, after the training, the brain is already learned how to do that task by using the memory. Now we can illustrate that as an artificial neural network. First, we have the input and the ground truth level of that input. And then we forward it into the neural network. And then the neural network will give some output. This is called forward propagation. And after we have the result of the forward propagation, we can compare the output with the ground truth level that have been provided. If the value is not true or not same, and we can calculate the loss or the difference between the output and the ground truth level. That loss then will be used for backward propagation or a repair of the neuron weight in the neural network. And after some training, the neural network then can predict the output based on the input. This is the deep learning trained model that can be used for the inference or the prediction process of an input. So you can see here, this is the process of using the deep learning model. First, we have the untrained neural network model that have no weight or have the initial weight. And then we do the training to the model using the training dataset. And after the training, we have the trained model that can do the prediction. And we can do the inference or the prediction of an input by using the new data on the trained model. So we can get the output based on the input that have been provided. So after we learn about how the deep learning model works, we know that the dataset is an important thing. So in this section, we will learn about some object detection dataset that can be used for training the deep learning object detection model. So the dataset is the data that will be needed in the training process of the deep learning neural network. There is a bunch of dataset that can be used for each problem that we want to solve. In this paper about the object detection, the author explains some of the object detection datasets such as Pascal Visual Object Class, Microsoft Common Object in Context, ImageNet, and etc. This is the example of the Pascal Visual Object Class dataset, which is contain the 20 class of object, and each image have the label or the ground truth of the object in the image. So we can provide this dataset into our deep learning model, and our deep learning model can train based on the dataset that have been provided. So after we learn how the deep learning model can work, now we can continue to learn how the object detection models can work. And in this section, we will learn how and which model that can be used for the object detection task. So before we go further, we need to know what is the definition of the object detection. As you can see in this image, there is three type of tasks that can be used using a deep learning model. The first one is the classification. In this classification, we will predict the object in one image, and the model will output the class of the object in the image. So for each image, the deep learning model will output only one class output or the prediction output. So this one just classified that in this image there is a object called bunny, and in the object detection, uh, Besides, we need to classify each object in the image. We need to locate the object in the image. So we have to output. For example, in this image, we will have three objects, which is object 1, object 2, and object 3. So we will have the class of object 1 and the bounding box of object 1. So, and so on and so forth. We have the class of object 2 and class of object 3 with the bounding box of each class prediction. So the object detection is basically predicting the object that are in the image with the localization or the bounding box of each object. And in segmentation, the task is more hard because we must predict the segment or the part of the object in the image. So if in this example, we will have to locate where is the duck and the bunny based on the pixel-wise object. So we will have the mask of the duck 1 and duck 2, and we will have the mask of the bunny. After we learn about the definition of object detection model in previous image, we knew that we need to do the object classification task in the object detection model. And we can use the convolutional neural network or CNN for doing the object classification task. And the CNN is a concept in neural network models that can be used for the image classification. And how does CNN works? Um, Basically, there is three component or three main process in the CNN model: the convolution, the pooling, and the fully connected layer. And the first one is the convolution. The convolution is the layer that we can use to extract the feature from the image. So this process is done by multiplying or convolving the image input with some filter or kernel to extract the feature from the image. The second one is the pooling layer. This process is needed to reduce the dimension of the layer that will be processed. We can use either average pooling or max pooling. Pooling can be useful for reducing the computational cost and prevent the overfitting. And last, we have the fully connected layer. The fully connected layer is the layer that we can use for classification, and we can classify the object based on the feature that have been learned and extracted by a previous layer. So we can have the output layer that match the class of the object in the image input based on the feature that have been learned by the CNN model. So after we learn about the CNN model, we need to learn about the object detection model. So first off, we need the backbone networks for our object detection model. The backbone network is a feature extractor for the deep learning model that will take the input image and give output the feature maps of the image that have been provided. We can choose several backbone network based on what we really need. Either is better accuracy, like using the ResNet, or better processing speed with like MobileNet. This is the graphic that gives some uh, example of the backbone network that we can use. Uh, there is a trade-off between the accuracy and the speed of the backbone network. So after we learn about the backbone of the object detection model, we need to learn about the architecture of the object detection model. Currently, there is two types of the object detection model architecture. The first one is the two-stage detector, or which is the regional CNN family, and the second one is the one-stage detector, which is the YOLO and single-shot detector model. Um, the difference between the two architecture is how the architecture do the object detection work or the task. In the two-stage detector, the architecture will do the object detection and the classification in the different pipeline. And in the one-stage detector, they will do the object detection and recognition in one single process. That's because in this two-stage detector, the model first will predict the location of the object. So we have the region of the interest or the bounding box, and then from that bounding box or region of interest, we can do the classification task for each region that we have. So we can get the output, which is the location and the class of the object in the image. But in the one-stage detector, the model will feed forward the whole image into the object detection model, and the object detection model will predict the location and the class of the object in the image in the same time. This can be done to reduce the time to do prediction, but this can also reducing the accuracy of the model. Uh, so there is a drawback between when you want to use the two-stage detector or do you want to use the one-stage detector. Okay, so after we learn about the type of the architecture of the object detection model that can be used, now we can continue about some example of the object detection model that can be used. The first one is the region-based convolutional neural network, or we can call it RCNN. This is one of the two-stage detector architecture type that can be used for object detection. So the process in this model is to find the region which is contain an object in the image, and then forward the region into the CNN model for prediction. There are two key features that use in this model, which is first, we use the selective search in the image to find a bunch of region of interest to forward into the CNN model. And then we can use the SVM or support vector matching classifier to classify the class in the region of interest to find the class of the object in each region. So, and the output is the bounding box and the class of the object in the image. Okay, and then the second one is that we can learn the fast RCMN model. This is the improvement of the RCMN model that increase the speed of the model by changing some part in the model. The change is instead using the selective search before the CNN model is processed. Uh, the model is inserting the whole image into the CNN model to extract the feature and reduce the whole of CNN operation. Imagine before this change, we will do CNN process in bunch of region proposal that will be processed with CNN. With this with this change, we will do just one time CNN process to extract the feature, and then we will do the region proposal to extract the to identify the localization of the feature in the image. And then the other change is the output layer. The output layer before is using the SVM or the support vector machine. We change it into the softmax layer to reduce the work of classifying. Because before using the SVM, we classify each class one by one. But using the classification layer or the softmax layer, we will just do the one operation, which is the softmax layer, and then we will get the probability of each class in the object list. So the third one is the faster RCNN model. This is the improvement of the fast RCNN model. The faster RCNN model is the improved model of the fast RCNN model by integrating the region proposal algorithm into the CNN model. This method doesn't use anymore the selective search algorithm because the algorithm is very slow to find the region of the object. Instead of using the selective search, uh, this model is using the region proposal network to predict the region proposal of the object. And then the predicted region proposal will be reshaped into the CNN using with the filter using the region of interest pooling layer. This one right here. And then the output will be used to classify the image and the proposed region and predict the offset value from the bounding box. So the output will be the object class and the object bounding box. Uh, this one is interesting because there is the new network that uh, do the searching for the region for that can improve the performance to predict the region of interest because they share the same computation in the network. So another object detection model that can be used is the mask RCNN. The mass RCNN is an improved model of the faster RCNN that can be used for the pixel level segmentation for object detection tasks. This model is using a binary classification for creating the object mask based on the class of the object. The result is the a mask of the object in the image in the pixel level segment. So as you can see in this image, the people in this image will have a mask segmentation that will be provided as output in the mask RCNN model. This model add another branch. This model adding another branch in the output. This one. So the output of convolutional network that convert the region of interest uh, into pixel level segmentation by using a fully connected layer. This model output is a mask, a bounding box, and a classification. So we have three output: the bounding blocks from the faster SNN part, and the mask and the class is and sorry, the class and the bounding box from the faster SNN model, and the mask from the branch that created in the output. And this model also replace the region of interest pooling layer into the region of interest line to improve the accuracy of the model to predict the pixel level masking of the object. So this network can be used uh, for getting the mass of the object in the image for what we need. Okay, the last one is the YOLO object detection model, or you only look once object detection model. So this is a proposed model by Joseph Redmond in CPPR 2016. Uh, this is improving the object detection task speed by combining all the part in the object detection task such as classification and the localization into a single unified network. This was created to achieve the real-time object detection that can be used for many tasks. This YOLO model is started by dividing the image that come into the network into the grid. This number of grid can be customized to choose between the accuracy and the speed of the model. Then we can calculate the predicted bounding box in each cell, and then each cell that contain the object that have the predicted value, we can do the classification task for each bounding box that have been created. And then the non-max suppression can be used to reduce the number of bounding box uh, that have been created. For example, look at the image here. We have a bunch of bounding box, and we use the non-max suppression to reduce the bounding box by combining the bounding box that have the uh, overlay each other. So the number of bounding box will be reduced, and then we can use the threshold to filter the value of the object in the bounding box that have been reduced in the previous process. So we can have the thicker bounding box that have the class and the location of the bounding box. So the final detection is the object bounding box and the class of the bounding box. So this process of combining the region proposal and the classification network into a single network is increasing much faster speed performance to do the inference. Uh, and the trade-off of uh, the accuracy and the speed uh, can be modified by changing the grid uh, that can be used in this model. And this model is very useful for real-time application that needed the real-time object detection task. Okay, after we learn about the deep learning model and how deep learning model can work, now we can learn how to improve the deep learning model by using some method. There are some methods that can be used for instance in enhancing the performance of the object detection model, such as the enhancing feature from the image. So we extract more feature from the image with better filter, and then improving the post-processing process with non-maximum suppression to reduce the workload of the model, and then increasing the localization accuracy in the dataset by uh, by using the more accurate localization of the bounding box and etc. This is some example of the improvement method, which is the non-maximum suppression. This is already been explained in the YOLO model, which is if we have some bounding box that overlap into each other, we can reduce the number of regions of interest that overlap by using the greedy algorithm to combine the region into one big region. So that from the bunch of bounding box like this, we will have the output with one bounding box like this because the region represent the object with the same texture or same feature. So after learning about what is the object detection model and how it works, now we can discuss about the application of the object detection model and what the deep learning model can do. So this is some example of the object detection model application. We can do the face detection using the object detection model. We just need to train the model to detect face. This application can be used for the security problem when we want to identify some person in a public place, or we can use it into a device for securing our door. And then the another application is the pedestrian detection. This can be used for many applications such as people counter in the public place, and for the autonomous vehicle or the autonomous mobile, we can use this for avoiding the pedestrian using the object detection to detect the pedestrian. And then we can use the object detection for another use, which is the computer aided diagnosis for the medical imaging. This object detection can be trained to locate and find the abnormalities in some image. So we can train it to, for example, detect some feature of some disease, and then we can train it with the dataset that have been gathered, and then we can use the model to predict, but it's just for the reference to the real doctor to diagnose the patient. So it's just create a probability of the disease, and many more applications that can be used using the object detection. Uh, there are there are many use of the object detection that can be uh, explored. So there uh, there is much more room to explore. Okay, the conclusion of this review is the object detection and classification have a vital part in the artificial intelligence development. And the increased capability of our computing system is really support us, the developer, to keep learning and develop the deep learning system. Also, the needs of more accurate and precise real-time system is become more urgent. So we need more development in this area to assist us in the daily life. In the end, there is much more to be explored with this concept of artificial intelligence and deep learning. Okay, thank you for your attention. That's all my presentation. If you have any question, you can contact me at this email. Thank you very much.